Okay, so let's take a closer look at this periodic table of the elements and figure out how it's all put together and why we need to study it in biology. So, um, this is page 5, lecture outline book, and as we said earlier, looking at protons, neutrons, and electrons, you put the right number of these and these and these together, you can build anything in the known universe. You can build an atom, a carbon atom, a nitrogen atom, a cell, a tree, whatever. So how does that all happen? Well, we need to stick with the atom level first. How do you put the right number of these and these and these together so that you can form an atom of carbon or an atom of nitrogen or an atom of oxygen, and then use those to build the complicated things like proteins and carbohydrates, etc., that we're looking to build? Well, to answer that question, you really need to be able to characterize an atom and what it is, and be able to identify some important features of each atom. So we're going to talk about the elements. If you look at an element, carbon is an element, nitrogen is an element, oxygen is an element. The smallest piece of that element that still has the properties of that element is an atom of that element. So it's just I like to think of the elements again as different flavors, if you will, or different versions of matter, each with their own individual properties. And the tiniest particle of that element that retains the properties of that element is an atom of that element. So we're going to need to understand a couple definitions before we translate what I just said into a periodic table. First of all, an atomic number. As we said earlier, all atoms have some protons in them. Well, how many protons? Each different type of atom has a different number of protons. The atomic number is simply the number of protons in an atom. So, for example, hydrogen atoms have just one proton, got an atomic number of 1. Helium atoms have 2 protons. Helium has an atomic number of 2, etc. And the atomic number is really the signature. It's the unique calling card. It's the unique feature of that element. You're never going to have an element of hydrogen have any number of protons other than 1. If you've got an atom with a number of protons different than 1, it's not hydrogen. That's the unique signature. So that atomic number is like I said, the defining feature of that element. We're going to draw some of these, and you'll see that in action in just a little bit. But another thing that we would like to know, not just the number of protons, but what about the number of neutrons and electrons? Let's figure out what that's about. Well, if you want to talk about and discuss any atom, you might want to know how massive it is. How much does it weigh? And we talked about atomic mass units, etc. And we also mentioned in the previous video that protons weigh 1 AMU, neutrons 1 AMU, and electrons are incredibly light. They're about a 2,000th, a 1980th of an AMU. Well, for our purposes in this course, we're going to say that the mass of any atom is simply the number of protons in that atom plus the number of neutrons in that atom. Because we're going to say the electrons are so incredibly light. Yes, they weigh something. Yes, there's matter there. But for our purposes, it's so little that we're going to ignore it. Now, that doesn't always work in all levels of chemistry, but it's going to work for us. So if you want to know the mass, or weight, if you will, of any given atom, just add up the number of protons and the number of neutrons. They each weigh 1 AMU, so just add them up. That's how many AMU the thing weighs. Conversely, if I want to know the number of neutrons, I can simply say, well, the atomic mass minus the atomic number is the number of neutrons. For example, I'm going to get the periodic table out here and show you an example of this. Let's look at the element beryllium. If you get your own periodic table out, like I said, it's in the last page of the lecture outline book. We're going to say beryllium is right there. If I look carefully, I've got 2 numbers in the box that says beryllium. It's symbolized Be. I've got a 4, and I've got a 9.01218. The 4, the whole number in any of these boxes, is the atomic number. So for beryllium, it's 4. There's 4 protons in a single beryllium atom. The 9.0, etc., is the atomic mass in AMU. For our purposes, we're going to round that number to the nearest whole number. So I'm going to take 9.01218 and round it to 9. So the atomic mass is 9 AMU. In other words, the number of protons plus the number of neutrons is 9. The number of protons is 4. So what's the number of neutrons? 9 minus 4 is 5. So just by looking at the periodic table, I can instantly know the number of protons, just look at the atomic number, and with a little quick subtraction, I can know the number of neutrons. Take the atomic mass and subtract the atomic number. In this case, 9 minus 4 is 5. So if I wanted to build a beryllium atom, and you say, well, how many protons do you need? 4. How many neutrons do you need? 5. That's 2 of the 3 relevant questions. I just need to now know how many electrons to put in, and I can build you a beryllium atom. So let's figure out how to do that. Let's focus in on the word atom to figure that out. By definition, an atom has a 0 net charge. It is not charged. So neutrons, remember, don't contribute anything to charge. They're neutral. Protons, there's 4 of them in a beryllium atom, have a positive electrical charge. If the whole beryllium atom has to have a 0 charge, and there are 4 positive things in it, there must also be 4 negative things in it, right, to cancel out the positives. So if I'm looking up a parts list for a beryllium atom, I'm going to need 4 electrons. So I need 4 protons, 5 neutrons, 4 electrons. Those are the parts that I need to build a beryllium. And if I turn the page, I've got a place to write all that. I've got a little square here to fill in the parts of a beryllium atom. The atomic mass, we said, is 9 AMU. The atomic number, we looked it up on the periodic table, is 4. Atomic number and number of protons means the same thing, so 4. The number of neutrons, previous page, we said 9 minus 4, 5. The number of electrons, electrons have to cancel the protons so that the whole thing is a 0 charge. So if there's 4 protons, there must be 4 electrons. There's your parts list to build a beryllium atom. Now, a little side note right now before we go further. Do not fall into the trap of defining the word atomic number as the number of electrons. The definition of the term atomic number is just what we wrote on the previous page. It's the number of protons in an atom. You may say, well, yeah, but it's the same. When we start talking about things like ions later on, we'll see that electrons come and go, protons don't. So the definition of atomic number is the number of protons. For what we're doing right now in this video, that number happens to be the same as the number of electrons. Okay, so if you said to me, build me a beryllium atom, I'm going to say, all right, give me 4 protons, 5 neutrons, and 4 electrons. Those are the parts I need. I need to now put them together, but those are the parts I need. Before I show you how to put them together, let me show you a common way to symbolize all of this much more concisely. It is not uncommon to see in textbooks and in writing a chemical symbol off the periodic table. Again, the periodic table has all the elements, and each one is symbolized with a 1 or 2 letter abbreviation. Beryllium is Be. And it's not uncommon to see the atomic mass, in this case 9, written before the symbol superscripted, and the atomic number written before the symbol subscripted. It's not okay to interchange them and put the 9 here and the 4 there. That doesn't work, okay? That doesn't mean anything. It doesn't exist if you flip-flop these. But the atomic mass in AMU right there, the atomic number, the number of protons right there, and the symbol tells you a lot of information without having to look it up. So if you want to be nice and talk about an element and not have somebody have to get a periodic table out, you can put the numbers there for them and they can just read that in a line of text and it's all summarized. So we'll put that off to the side, and that's what that means. Okay, now the next thing to figure out is how are we going to put all this together? You have to take these parts, 4 of these, 5 of these, 4 of these, and arrange them in just the right way to have a beryllium atom. If you don't arrange them right, you just got a pile of protons and neutrons and electrons. Got to put them together in the right way. It's like any kind of construction. You know, if I want to build a tool shed, I need some lumber and some bricks and some screws. I don't just throw them into a pile and say, hey, I have a tool shed. No, I have to assemble them in just the right way to have the device that I want, to have the final product that I want. So how do you put these particles together to build, in this case, a beryllium atom? We're going to look at that in the next video. In the meantime, review what we've done. Make sure you can do this for a couple of other atoms. In other words, before we fill in anything else in these boxes, go ahead over the next couple of pages before you look at the next video and just fill in parts lists. Go to nitrogen on the periodic table. Nitrogen is over here. And ask yourself, well, how many protons should it have? How many neutrons? How many electrons? Write it all down. There's a couple more pages with more elements off the periodic table. So familiarize yourself with the table, but familiarize yourself most importantly with how to translate these numbers from the periodic table to something like this. So fill in those portions of the next few pages, and then in the next video I'll show you how to put the parts together and actually assemble these things into an atom.